Hi, this lesson is on finding the domain and simplifying rational expressions. The two of them sort of go along together, so that's what we're going to do with these problems. To start off with, we know that a rational expression is any expression in the form of A over B, where A and B are polynomials. We also know that with any rational expression, B, which is the denominator, cannot be equal to 0. This is what we're going to use to find our domain. Of course, we're going to be given a rational expression. And to simplify, what we're going to do is simply divide out common factors. If you have 4/6, that's just a fraction. What's it have to do with this lesson? 4/6 is actually a rational expression. It's a simple rational expression. It has no variables in it. But when you look at 4/6, you say that 4 is 2 times 2, and 6 is 2 times 3. If I divide out the 2's, that's the same as 2 over 3, or 2/3. That's the method we're going to use to simplify rational expressions. So, let's look at some sample problems. The problem we're going to start with is x squared minus 2x minus 63 over x squared plus 5x minus 14. When students are first learning to work with rational expressions, one of the first things they want to do, which is an error, well, I've got an x squared up here and an x squared down here, I'm just going to cross those out. You can't do that. X squared is not a factor. The only way you can divide something out is if it's a factor. We don't divide out terms. So, first thing we're going to do is look at the denominator. Whether we are just simplifying or finding the domain, we need to factor this denominator. The domain is anything as long as the denominator is not equal to 0. So, to find out when this denominator is equal to 0, we're going to start by factoring it. If we factor that using the factoring methods in one of my other videos that you can look back on if you're having trouble with this, the signs are going to be different. I need a product of 14 that has a difference of 5. Well, that would be 7 and 2. And the 7 is going to be positive. So those are my factors. Now, to find the domain is everything as long as x plus 7 is not equal to 0 and x minus 2 is not equal to 0. So the domain would be all numbers as long as x is not equal to -7 or 2. That would be the only thing that you could not have in the domain, because that would give you a 0 in the denominator. Now, in order to simplify, I already said we can factor out common factors, so we need to factor the numerator. We can do that the same way we did the denominator. We're going to put an x there and there. The signs are going to be different, so I'm going to put plus and a minus. I need factors of 63 that have a difference of 2. Well, that would be 9 and 7. The 9 has to be negative, so I'm going to put the 9 there and the 7 there. I have x plus 7 in the numerator and the denominator. So we're going to divide those out. And that means my remaining expression is x minus 9 over x minus 2. Now, I still cannot have a negative 7 or a 2 in the denominator. Why can't I have negative 7? Because in the original expression, that would have given me a 0 in the denominator. Okay, let's look at another example. N squared plus 11n plus 18 over n squared plus 8n minus 9. Again, we're going to look at the denominator first. In the denominator, I have n. The signs are going to be different. And the factors are going to be 9 and 1. The 9 has to be positive. The 1 is going to be negative. And that means for the domain is going to be all real numbers as long as n is not equal to negative 9 or 1. If I factor the numerator, again, I'm going to have n. In the numerator, the signs are going to be the same. I need a product of 18 that gives me a sum of 11. And that's going to be 9 and 2. So for this problem, the n plus 9's divide out. And that will leave me with n plus 2 over n minus 1. And we still have the domain is all n that's not equal to negative 9 or 1. Some of you might be able to look at this and say, oh, I know what divides out, and go ahead and divide it out. I really think it's a good idea if you write out the factored form before you just start doing things, because you need to make sure that you don't make any careless mistakes when you're doing that. And when you see the factored form, it's going to make it easier for you to see what you're working with. Again, starting with the denominator, I can factor out a 10, and that's going to leave me with n plus 1. So for the domain, well, the domain is going to be all real numbers as long as this is not equal to 0. Well, I know that 10's not equal to 0, so I have n plus 1 is not equal to 0. That means n cannot be equal to negative 1. If I factor the numerator is however, I know that I have a factor of 5 in the numerator, and 5 goes into 10 2 times. So in this case, my simplified expression is 3n plus 1 over 2 times n plus 1. You can leave it like that, or if you wanted to, you could make that 2n plus 2. But often we end up leaving them in factored form. I have a whole page of these. We could just keep doing these all day long. Let's look at one more example here. This is a good one. 2x squared minus 24x plus 70 over 2x cubed minus 20x squared plus 50x. Oh no, we have an x cubed. What are we going to do? No problem. Look for the greatest common factor. The greatest common factor for the denominator is 2x. When you factor out the 2x, I'm going to actually do that here. That's going to leave you with x squared minus 10x plus 25. Now you have a quadratic that you can factor. That factors into x. The signs are the same. They're both going to be minuses. And it's going to end up being x minus 5 times x minus 5. Now, we did take out a factor of x. That means for the domain, that denominator has x that cannot be equal to 0. And we have x minus 5 that cannot be equal to 0. Now that's a factor twice, but we only have to write it once. That gives us x cannot be equal to 5. So our domain is all real numbers as long as x is not 0 or 5. Looking up here, if we factor the numerator, we can factor a 2 out of the numerator. And if we factor a 2 out of the numerator, it's going to give us x squared minus 12x plus 35. And when we factor that quadratic, we're going to end up with x. We've got the same signs, they're both minuses, and a product of 35 that has a sum of 12. That would be 5 and 7. Again, the signs are the same, so it doesn't matter where we put those. We have an x minus 5 and a 2 in both the numerator and the denominator. So those are what we're going to divide out. This is going to leave us with a simplified expression of x minus 7 over x times x minus 5. That brings us to the end of this video. If you have any questions at all on how to simplify rational expressions or find the domain, just contact me by using Blackboard. You can email me or you can post a question on the discussion board.